Hi, welcome back to video 2. Now what I'd like to do is look at the spreadsheet that we left off on before break. This is the one using the GDP data, not the one where I was forecasting what was happening with coronavirus. And so our spreadsheet looked like this. And from this, we had produced this chart. This is actually case 3. It was unlabeled. It looks pretty good. And what we had discussed at the very end of class but not actually done is calculated the residuals over here. So if we look over here at the very beginning right here, the fitted value is above the actual value. The orange is above the blue. So that means the residual is that negative distance right there. So back over here, we're going to create the residual as the difference between the two columns just to the left. So that's E21 minus F21, like so. Okay, and then we're going to copy that down. And the important point that we want to look at here is, does it roughly match up with where the recessions and expansions are in the data? So I'm going to go down to the end where maybe we know it a little bit better. Okay, and we should, okay, around recession years, see larger negative residuals. Now, they are residuals. We should see them distributed kind of around zero, okay? So you shouldn't be shocked that, say, 1995 got a negative value here when 1995 was a good year, okay? But it was surrounded by these other good years. But if we go back to 1991, which was a recession year, we get a residual that's both negative and considerably larger than the ones around it, okay? Going back further, most of the 80s look pretty good, but you go back to 1982, which was a bad year, and you again have a big residual. You go back to 1980, which had that sharp, nasty short recession, big negative residual. You go back to 73, 74, 75, and again you've got negative residuals. 73 I'm not too surprised about because that was actually a pretty good year for the economy. But that's when, in the early October, when the Arabs invaded Israel in the fourth Arab-Israeli war, that the first oil embargo was put in place by OPEC. So that was a recession that certainly was brought on by OPEC at the end of 1973. So probably maybe if we could incorporate something for that and have, a finer level monthly data, we might find that these shocks were positive through most of the year but negative at the very end. So the 0.022 is okay. Going back further, there's 1970, big negative shock. Going back through the 60s, okay, we had a very mild recession in 1960 with a couple of small negative shocks there. We had a nasty one in 58 with a negative shock, okay. And when we go back to the Great Depression, we see the very strong negative shocks at the beginning. A bit of a pickup in 34, 35, 36, 37, but again, another nasty shock in 38 as the second recession hit us. And when we get into World War II, we see the really strong shocks in 41, 42, 43, kind of tailing off in 44. If you're a World War II history buff, you're probably pretty well aware that the industrial ramp up by the Roosevelt administration kind of started in mid to late 1940. So it's not surprising that we get this big shock in 1941, even though Pearl Harbor was at the very end of the year. So I think that this case 3 actually fits really, really well. It, of course, is a very simple model, and the problem with it, as I mentioned in the earlier video, is this coefficient here that's close to 1 but not exactly 1, and has a 95% confidence interval that actually includes 1. So what that large shock but not equal to 1 coefficient means is that shocks to the economy are very, very long-lived. As that coefficient gets closer to 1, they get stretched out longer and longer and longer, okay? But that the economy has no trend whatsoever to it. So essentially, the last 300 years of human civilization where things have been so good is the upswing of a very, very big long hump. you could actually do the math and you'd probably find out that that might last a couple thousand years. Maybe that's true. Certainly, I think that's what some environmentalists believe. Um, I don't really have too much of a problem with that. I think what's important for us in our lifetime is that very um, persistent but still transitory is not that much different from permanent. And we get permanent shocks when we restrict this coefficient to be equal to 1. Now, as I've mentioned both in class and that other video, Excel can't do that, but Stata can. Um, but it turns out in Excel we can fake it. Okay, so I'll show you how to fake that regression in Excel. This is not a technique that you really need to learn for other classes. It's just kind of proof of principle that it's possible. So I'm going to go back to my data page and do the same things I've done before, where I'm going to create a new data set. But what I'm going to do here is have the differences of log GDP here, okay, rather than the actual levels, okay. Um, so I'm looking over this and that's weird. Okay, yeah, I think that that's okay. All right, so when we did our last regression, we did it using these two columns right here. Okay, so now what I'm going to do is I'm going to take the difference between those two columns. So that is going to be J13 minus K13. Okay, so since we're in logs, that's an approximate growth rate. And I'm going to call this delta. There it is. Delta log, whoops, GDP-CA. Okay. And over here, I'm going to label this column intercept. And I'm going to put a 1 in there. And then I'm going to take these two things and I'm going to copy them all the way down. Okay. So what I'm going to do is I'm going to fake Excel out by coding my intercept here by hand as a column of 1s. And then I'm going to run my regression normally. So I go down here, and what I'm going to regress is that log's difference log there. Okay, and I'm going to regress it on this intercept right here. And I do have labels there, so I'm going to click that checkbox. But what I'm going to click also here is constant is 0, because what I'm doing here is suppressing the constant that Excel wants to put in on its own and doing my own. Okay, so if I click OK, this should work, and it does. Here's my new sheet. I'm going to do the same thing I always do. I'm going to do an Alt-OCA so I can fit everything. I'm going to do an Alt-OE to reduce the number of digits. I'm going to do an Alt-HAC to center everything. Okay, and then I'm going to label what I did, and I'm going to call this case 4, regression of approximate growth rates on an intercept only. And then put in the dates 1930 to 1996. And I'll do an Alt-HAL to get that visible. Okay, so what's going on here is that this row is the intercept that Excel wants to put on it in on its own that I suppressed, and this row here is the intercept that I put in. And so what that's telling us is that we get a average growth rate for real GDP of 3.2%, okay, with a fairly small standard error, okay, fairly tight 95% confidence interval. Okay, up here, my R squared is no longer near as high. I'm not getting those 98 or 99% things, but this is because I'm not fitting a trend anymore. I'm fitting growth rates which jump around a lot. So maybe getting 30% fit on those is a good thing. But this standard error, okay, I'm going to show is the exact same standard error that we've had for cases 1, 2, and 3 when the dependent variable was in levels. So we've gone from like 12% to 5.5% to under 5% in this model. So that's an improvement. Okay, that's enough for this video. Okay, this is the model we're going to go forward with from here on out. Okay, I'll introduce case 5, which is a modification of this one, after I discuss the theory of this one a little bit in a third video. Bye!